Welcome to lesson 5, sets, absolute value, and addition of signed numbers. Okay, we're going to talk about sets first of all. A set is a group or collection of items. Now, you can think of these as, well, they could be a group of numbers, or really a set can be a group of anything. Maybe you collect baseball cards or some sort of, I don't know, figurines or Matchbox cards or something like that. I don't know. But everything in your entire collection is called the set. Now, each one of those little baseball cards or figurines or dolls or Matchbox cards, each one of those is an element to the bigger unit, the set. Okay? Now, the way we denote a set is by closing the elements with braces. So here's how this may look. Here's set A. Notice that set A has all of its elements closed in with braces. Now these braces look like this. Okay. Our elements are 1, 3, 5, 7, and 9. This is read set A, which contains 1, 3, 5, 7, and 9. All right. Now let's do a little bit of practice with these sets. We're going to create some sets from this list of numbers up here. So our numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Set B, the even numbers. So set B is equal to, let's start some braces, and now the even numbers. Well, the even numbers will be 2, 4, 6, 8, and 10. So 2, 4, 6, 8, and 10. Let's create set C, whose numbers are numbers greater than 5. All the numbers greater than 5 are 6 through 10. So set C contains 6, 7, 8, 9, and 10. Finally, set D, the numbers that are greater than 10. So let's try to find the numbers that are bigger than 10. Well, there are no numbers bigger than 10, are there? Okay, so what we can do is just leave set D empty like this. This is called the empty set. It has no members. Or we can write this symbol. This is called the null set, N-U-L-L set. It means empty or nothing. Okay? More on this later. Let's talk about absolute value now. Absolute value is nothing more than a number's distance from the number 0. For instance, 7 is 7 units from 0. However, negative 7 is also 7 units from 0. And this is actually the exact example I used on the last lesson when we were talking about distance from 0 and opposites. So we say the absolute value, written the absolute value symbols, which are 2 vertical bars around the number, is 7. But the absolute value of negative 7 is also 7. It's just distance from 0. There's no such thing as a negative distance. So that's why absolute value always turns out positive. Okay, let's try an example. The absolute value of negative 5 is just 5 because negative 5 is 5 units from 0. You'll see a lot of these as we progress through our problem sets now, absolute values in equations. So we have the absolute value of 11, which is 11, minus the absolute value of negative 4, which is 4. Now this problem just becomes an easy 11 minus 4, which is 7. Okay. Notice that I took the absolute value of the numbers first and then performed the operation in between them, which is a little different than number 3, where the entire numbers and the operation are inside the absolute value bars. I have to do the subtraction first, then take the absolute value of it. So 11 minus 3, that gives me an easy 8. Notice my absolute value bars are still there. Absolute value of 8 is 8. Now, if this would have turned out to be a negative, let's say 5 minus 7 with absolute value bars around it. Let's call this number 4. 5 minus 7 leaves me with a negative 2. But the absolute value of negative 2, positive 2. So in this extra problem here, notice how the original subtraction led me to negative, but the absolute value brought me back to positive. Okay, let's go to the back. And talk about addition and subtraction with signed numbers. All right. On the number line here, we're going to show the addition of 5 and -3. Now, if I use this as my 0 point right here, 5 will be up here somewhere. Now, -3 implies that I'm going to move to the left. Negative numbers always go to the left. Positives always go to the right. So from 5, I'm going to move backwards 3 places. So I'm starting here. And I need to go back 1, 2, 3. And I end up at 2, which means 5 plus a -3 equals 2. And we just confirmed that on our number line. Here's our -3 right here. Started at 5 plus a -3 equal 2. Okay, let's try another one. On the number line, let's show the addition of -6 and 2. -6 might be down here somewhere. Definitely on this side of 0, right? On the left-hand side of 0. So here we have -5. Here's -4, -3, -2, whoops, -2, and -1. Okay, so this time we're starting here at a negative, and we're adding a +2. That means we're going to go 2 to the right. So 1, 2. And we end up at -4. That means -6 plus 2 equal -4. Our last example for this lesson will be show the addition of 3 and -5. So here's 1, here's 2, and here's 3. Zeros right here. And go ahead and fill some negatives in on your number line because we're going to need them. Okay, starting here at +3. And we're going to add -5. But remember that negative means to go to the left. So here we go. 1, 2, 3, 4, 5. And I end up at -2. So that means 3 plus a -5 equals -2. And we just proved it right there with our number line. Okay, this concludes lesson 5, sets, absolute values, and addition of signed numbers.